To understand how EDM removes metal, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches the electrode and part, an intense electrical field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrate at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductive bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and workpiece at the points of spark contact. A bubble, composed of gaseous byproducts of vaporization, rapidly expands outward from the spark channel. Once the pulse ends, the spark and heating action stop, collapsing the spark channel. Dielectric fluid then rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of material and gas bubbles. The resulting EDM'd part can have several observable surface layers. The top surface layer is created when expelled molten metal and small amounts of electrode material form spheres and spatter the surface. This layer is easily removed. The next layer is a recast or white layer, where EDMing has altered the workpiece metallurgical structure. This layer can be reduced using the right control settings or by polishing the part. The third layer is the heat-affected zone or annealed layer. It has only been heated, not melted. In RAM EDM machines, the workpiece mounts inside a tank and is covered with dielectric fluid. An electrode then lowers to within a few thousandths of an inch of the workpiece to begin EDMing. RAM-type EDMs have the ability to produce complex cavities out of a solid piece of metal. RAM EDM machines are also referred to as die sinkers or vertical EDMs and range in size and automation, from manually operated tabletop systems to large bed manual or computer numerical control systems. A RAM EDM has four major subsystems: a power supply, a dielectric system, an electrode, and a servo system. CNC wire-cut EDM machines use a traveling wire electrode to cut complex outlines and fine details in stamping and blanking dies of pre-hardened tool steel. The wire drive system continuously delivers fresh wire under constant tension to the work area, guided by a set of sapphire or diamond wire guides. New wire is always exposed to the part, so electrode wear isn't a problem like in RAM EDMing. Wire EDM machines are also easier to learn than RAM EDM. They can run unattended for long periods, including overnight and weekends. There are four basic wire EDM subsystems, all of which are CNC controlled. Those subsystems include the power supply, the dielectric system, the wire feeding system, and the positioning system.